So table 3, we'll start with you. You should have used technology to create a dot plot, and first you needed to describe the shape of it. So how would you describe the shape? Bell shape. You're not close to the TV, but I'll take that so far. When you graph your dot plot, it should be bell shaped. So then the actual reporter, can you tell me another phrase we use to describe our data distribution that looks like a bell shape? All right, class helper out. If it's bell shaped, it's also symmetric. Okay, there's only a few shapes we learn. Many of them can be many of them can be symmetric. And the reason why it's important to tell if it's symmetric or not is because there are going to be times where you can say the mean or median without doing any of the math if it's symmetric. So that's what we're going to talk about today. I should have typed it up while I was waiting, but I'll do it right now. You all learned how to make a dot plot with technology and by hand, but we're using technology today to make it faster. What's the first thing I need to press if I'm trying to make a dot plot on here? Yes. Okay, B equals, or some other letter equals, but then what else? A bracket. That way it pops up something like this. And then all you have to do is type in your data. You have to know how to make your calculator think, basically. So let me real quick, I should have done this already, but I'll just do it really quick right now. So if you haven't done it yet, maybe you do it really quick right now. Okay, so initially in my original data set, I have 18 data points. And then you can also use your technology to easily find the mean and median. Can you tell me the mean of the original data set? Not mean. That's the mean. Come on, guys, when I give you 5 minutes, I should expect at least the first few problems to be answered. Or at least you could ask your group, or at least you could ask me. But like, this is unacceptable. Either know how to do it by hand or know how to do it with technology. It is 10. Because of a few reasons. One, when I check it with technology, it is 10 for the mean of my original data set. And then table 4, what's my median? 10 as well. So I'm going to type that in now. Hopefully we're taking good notes, especially if we didn't know how to get to this point. As you can see, it is as well for the mean. Now I need to also show you the dot plot. I kind of skipped over that part. How do I make it create a dot plot for me? Okay, you could just type in dot plot, or you can find it in your functions menu. You just might have to scroll a bit until you see it. But yeah, I could also just type it in, and we can see it is bell shaped and it is symmetric. Look at where the 10 is. How would you describe where the 10 is in relation to the shape? Overthink it. How would you describe where the 10 is in relation to the shape? Yes, in the middle. If I were to draw a line of symmetry down the middle of the 10 is where it's symmetric on both sides, where it's near images. What you will come to realize is that if it is perfectly bell shaped like this, or it's perfectly symmetric, the mean and median will always be that middle number without doing any of the math. But you could always do the math or use the technology. Okay. So that was the first part. Now we wanted you to change the data a little bit. So you had to find the mean and median of the data with 2 additional values described below. So does that mean we're removing any values? No, you're just adding 2 that meet the criteria that it says there. So table 5, we need to add 2 values to the original data set that are greater than 14. What 2 numbers did you pick? $16 and $17. Both are greater than 14. You guys, the rest of you could have picked a different pair of values, so long as they are greater than 14 is what we care about. So see what happened to our data distribution. Is it still perfectly symmetric? Not perfectly, still for the most part, it is bell-shaped, but it's starting to skew a bit because we added 2 points on the higher end. So that may or may not adjust our mean and median. I'm going to rearrange this, that way when I change the data, how it affects the mean, which is what you guys should have seen on your own already. So now we have those 2 values greater than 14 added to our data. And now on my screen, you can, if you didn't for some reason, you can see how it changes the mean and median. So table 6, how would you describe the mean changing when we add numbers bigger than the rest of the data set? Would you say that it increased, decreased, or stayed the same? Increase. I mean, you could be specific on what it increased to, but all of us probably chose different numbers. If you added 2 numbers that are bigger than the rest of your data, the mean should increase. Did the median increase? It did not, it stayed the same, and that should be true for the rest of you. Even if you chose other numbers, the median stayed the same. Because how do you find the median by hand? Emberlyn?
You add up all like the numbers that you have, and then you divide by the value of numbers. So like a number, oh my gosh, how many numbers you have by how many they all equal.
So that's a great definition for how you find the mean by hand. So
Oh,
that's
mean.
why when I add numbers bigger to my data set, that will increase my average for sure. Without me even doing the math, I could tell you it will increase it. But for the median, someone else want to try? How do I find the median by hand? Yes, the way I'm practicing it because
You take the number in the middle of
you find whatever your middle number is. So like you go left, right, until you get a middle number or middle 2 numbers. But there are enough 10s in the middle that our median didn't change. So sometimes it'll change, sometimes it won't, depending on where you move it. But when you move it to the outer edges, it might not change. Okay, questions on that? All right, so then table 7. You needed to add 2 values to the original data that are less than 6. So I'm going to erase those others that we added before. So table 7, give me 2 values that are less than 6. 3 and 4. Easy. So while you could always type it in and check, you can also predict if I'm adding two numbers on the lower end, what is that probably gonna do to my mean? It's gonna decrease it if I add two numbers that are smaller than the rest of my data. But you could also do the math and see it went from 10 to 9.35. Did our median change when we did that?
No.
No, so maybe make a note of that. No matter what numbers you pick, so long as they are less than 6. The mean should decrease. And the median should stay the same. Okay. Now, table 8, we're gonna add a value that's greater than 14 and a value that's less than 6. So table 8, give me two values that meet that criteria.
And 2.
16 and 2. All right, so see how that changed our dot plot? Now we added one data point on each end. Would that change my median? All right, as you can see, no. If I'm adding something on each end, same amount on each end, it shouldn't affect my middle number at all, right? So my median definitely stays the same. Could the mean, or let me say this differently. Will the mean always change? When I add a number on the high end and the low end? Let's see if I can make it to where it doesn't change. Let me just try. Okay, so now I added a number smaller than 6, a number greater than 14, and my mean now doesn't change. So it just depends. When you add a number on the high and lower end, then it could change the mean, it could not. You could make it increase or decrease, you just have to kind of check that one and see. All right. So when in doubt, just check and see. Mean can vary as well, but for like whatever you guys. wrote down. Questions so far? All right, so now I'm gonna erase those two values I added, and it wants us to add 50 and 100 to our original data set. Now, before I even do that, think about it, don't say it out loud. Think about how it will change the mean, if it will. And then think about how it will change the median, if it will. Think about it. All right. So I'm gonna add the 50 and the 100 to the original data. I had to zoom out because where I was zoomed into, you would not see my two data points be added to my dot plot. And see how that affected my mean and median. So I could tell you without doing the math, if I add a number that is way bigger than the rest of my data set, the mean will absolutely increase. But why did the median not increase? Even though we added two way bigger numbers, why did the median stay the same again? Yes, like. Because there's still a bunch of 10s in the middle. I added numbers to the edge of my data, not the middle of my data. So it really just depends. You could still change it sometimes, but if there's a lot of the same number in the middle, it might not. So good exercise, hopefully you're seeing kind of the pattern, but when in doubt, you could always check the math on your test if you have time. So questions, comments? All right, so today we are on, it's like a combo lesson, 10 and 14. They're both about outliers. So today we are going to investigate outliers and how to deal with them. Using the shape of the distribution to compare the mean and median. Finding values that are outliers, investigate why they are probably there. And figure out what to do with them. And tell how an outlier will impact the mean, median, IQR, or standard deviation. That's how you'll know you're successful after the lesson. You'd like to check every single one of them off. I'm recording right now. I record every day and put it in this slideshow every day. There's one for every day. Even if I don't put it up on the screen, it's there. There's also videos from previous years. If you ever are working ahead, maybe you know you're going to be out of town or something. Regardless, like, and I sometimes have kids that are gone for a really long time. And like, they have legitimate reasons and blah, blah, blah. Regardless, like, everyone still takes the same test. Everyone still has like to take the same final exam. You have to know the material, like, there's just no replacement for that. So should that ever happen at some point, you know where to find everything for this class. The practice today is 2 separate ones, but they're both very short. So no complaints. I try to always keep your practices short and what's needed to make sure that you at least like read them so you can see what your quizzes will probably be like. And we were supposed to have a quiz today, but after seeing how long it took in first hour, I'm moving it to tomorrow. So keep in mind, tomorrow's also an assembly day. Classes are just a little bit shorter, but however far we get tomorrow in our lesson, we're gonna stop and take that quiz. So make sure your notes are ready, they're helpful to you. I feel like unit 1, it's kind of hard to know what to write down all the time, but because most of the time I'm just showing you and teaching you on the screen. But it's all on you to make sure they're helpful to you. Exactly. I only expect the parts that we do in class to be done, but if you want to go beyond that, go ahead. All right, so back to this. We are going to look at this page, the second page. So you have 2 different data displays. In your brain, think of something you notice, wonder, and then we're also gonna add, what can you infer? So based on what you see, what assumptions can you make? So think about that yourself. I'm gonna call on some of you. Still the same reporter for now, but it will change. So we're always ready, always on. A reporter for table 9, tell me something that you noticed. Okay, a line graph. Is that the proper name we would use for either of these? Okay, so we definitely have a histogram. Class, what are some pros of using a histogram? Like, what can we easily see on histograms? The numbers of. Because, I mean, there's numbers on lots of stuff. What'd you say? Like overall range? So I would disagree that on a histogram, you can see the range. On a box plot, which is down here. I think you could see the range pretty easily. How do you find the range? Like normal range, yes? Close, maximum minus the minimum, so this should never be negative, right? But in a box plot, since I can see my minimum and my maximum, I can tell the range from a box plot, but not a histogram. Because histograms don't tell me what my data points are. It tells me how many of them I have. So what's my y-axis of my histogram always? Frequency. So they don't always write that, but it should be known. The y-axis tells you the frequency, how often something occurred from 1 to 2, and 2 to 3, and 3 to 4, okay? Or how many data points you have total. It would be whatever 7 plus 8 plus 3 plus 8 plus 6 plus 1 plus 1 is. And that would be my total data set. You can't see that in the box plot. Table 1, give me one more notice. Okay, there's a potential outlier. Where's the outlier from? So on the histogram, it's easier to see potential outliers. You'll see why I say potential in a second. And what is an outlier, like in simple terms? Yes,
A number like way out of the average of the other numbers.
so a number that is really far away from the rest of the data, but it could be on the higher end, it could be on the lower end. Most of the time you can assume that something's an outlier, but today you're gonna learn how to like mathematically prove, because sometimes it's not always that. Outlier, think outcast, something that's really far away from everything else. I think that's good. Anyone have any wonders that they want to share really badly? Okay, table, or let me ask the whole class, because I guess that one's a little harder, it's a little fewer. Anyone have a good inference that you can make based on what you see here? So I know that one's a little harder, but relate it back to like the real world. This is supposed to be per capita health spending by country. There's one country that seems to be spending way more. You could infer what that country probably is. Say that's USA. I don't know. But that's what we mean by what inference we think. Does that mean we should exclude it from our data? I don't know. That's just one of our living targets. We'll see what to exclude and what. Okay, so good. Moving on. Right here, this is on your paper. It says one value in the set is an outlier. Which one is it? And what is its approximate value? So we already pointed this one. Hold on. We already pointed to this one being a potential outlier, but now we want to know what its approximate value is. So table, well, first let's rotate the report. Whoever spoke for your group last, go one to the left. So table 2, in which display is it easier to approximate the value of the outlier? Alright, everyone listen. I know you might not want to speak, but you will all speak at some point. Please, like, don't make it harder than it needs to be. So table 2. Which data display, the histogram or the box plot, would be easier to approximate the value of the outlier? Okay, I would have to disagree. So the box plot I think would be easier to approximate the value of our outlier, because in box plots, you can see the maximum. And clearly our outlier is gonna be like the maximum, there's only one data point in that bar. In histograms, it doesn't tell you, it just tells you it's somewhere from 9 to 10. Here you could kind of see, I know it's not 10 exactly, because if it was, our histogram would have a bar here instead, coming out of the 10. So it's not 10 exactly. What's the number that's close to 10? No, no less. Like 9.9 would probably be a good approximation. See like how it falls on the number line. Not 10 exactly, then that would change the histogram. All right. Now I'm gonna teach you that there is a rule for determining if something is truly an outlier or not. And that is if it is 1.5 times greater than the IQR or less than the IQR. How do you find IQR? Q3 minus Q1. It is so important that you know that. You need it for a lot of stuff. Make flashcards if you need to. But Q3 minus Q1 is IQR. Let's talk about box plots for a second. I said you can see the maximum really easy. What else can you see on it really easy? Minimum. What else? Median is this middle bar. And then what else? Q1 and good. So that's the 5 numbers we need to make a box plot. So I'm going to show you a visualization. If IQR is Q3 minus Q1, the box itself can tell you the IQR. So we'll look at the next picture. Okay, here. So we know the box itself of any data set on a box plot can tell us the IQR. Outliers are numbers that are 1.5 times the IQR greater than the box itself. And 1.5 times the IQR less than the box itself. So like for this random data set that you don't have on your paper, it looks like all numbers that are smaller than 3 are outliers on this one. And then over here, it looks like all numbers that are greater than 19 are outliers. That's how you can like mathematically prove that something's an outlier. So in short, you do have space on your paper to write your own definition for how to tell if something's an outlier. That's my definition. I mean, if you don't understand it, make it something that you understand. But since the edges of our box are Q3 and Q1, this is how you would determine for data points that are a lot smaller than the rest of your data and a lot bigger than the rest of your data. So take a moment, write it down, maybe revise it in your own words if you need to. Because then I'm gonna point you somewhere else to see if something's an outlier. Okay, I'll probably rewrite this part on the next page, so don't freak out. But you are gonna look at page 3 in your packet, where you have data for the number of property crime reported for 50 colleges in California, that one that already has the statistics for you. You're going to determine if any of those values are outliers using these rules and what you know about outliers. We're not doing this one, although that is from the data displays. You probably find those notes in Schoology if you really want another example. We're gonna look at this one. It's more user friendly, it gives you the statistics already, hopefully you know how to find these if it wasn't given to you. Do we have enough information to make a box plot? We do, we have our 5-number summary right here. Alright, so use those rules to determine are any of these outliers. If you find it, the answer, move on to the rest of those questions. Why do you think they might exist? Should we exclude them? Blah, blah, blah. I'll give you 5 minutes. Okay, so I see a lot of you typing in all this data yourself into Desmos. You didn't need to, because it already has the statistics right here that you need. Okay. Did, great, you got a little more practice, but all you need to determine if something's an outlier is the IQR and some other stuff, but like the IQR especially. Table 4. Well, first, before I ask you about that stuff. Table 4, do you have any predictions about which of these numbers, if any, are outliers? Okay. Okay. Does anyone else think that any other numbers could be outlier? Yes, Haley? Okay, 593. Can we have more than one outlier? Yeah, like if we look at that other visual example of an outlier. Pull that back up. I mean, you can't tell how many data points are here to here. But like for this random box plot, any numbers below 3, it looks like there could be multiple below 3. I think it's an outlier. It looks like any above 42.5, there could be multiple right here that do that. So yeah, you can have outliers on both ends. You can have more than one. Could you have outliers in the middle of your data? Okay, no, it cannot be in the middle of your data if it's an outlier. It's either on each end, there can be multiple. Anyone think that 15 is an outlier? Okay, so let's see. Table 5, how do I find IQR? And both of those values are right here. So I just have to subtract Q3 minus Q1. So 260 minus 52. Don't be ashamed to use a calculator for that. I still do just to make sure. But 208 is my IQR. So I need it to be, if we're checking on the higher end, if it is 1.5 times the IQR plus whatever Q3 is greater, then it's an outlier. So let's see. My Q3 is 260 plus 1.5 times our IQR, which is 208. Any numbers above 572 are outliers. So are classmates correct in choosing those 3? 593, 699, 768, are those all above 572? So yes, all 3 of those are outliers, good. 555 is not, because it would be smaller than like our threshold, make sense? If we wanted to see whether any numbers on the lower end were outliers, we would have to compare it to quartile 1. So quartile 1 was 52. And then it'd have to be minus. Anything below Q1 minus 1.5 times the IQR. So anything below negative 260 is also an outlier. Do I have any numbers below negative 260? No. So there's no lower outlier. Questions, comments, concerns? Again, you can always assume, but you know, if you can calculate it for sure, then you'll probably see that on your final. No for sure. Now, the other part of our learning target, why do we think those outliers might exist? So tie it back to the real world situation. See what this represents. So number of property crimes such as theft on 50 colleges in California are given here. Do you think that these are really like unreasonable numbers? Why might there be way more theft on some colleges? Are all parts of California the same, like equally as safe? That's like every state, right? There's parts of Arizona that aren't that safe, right? Should we exclude those data points from the rest of our data? All right, I would say no. I mean, if we're trying to show like on average how much property theft there is in California colleges, then I would probably leave those straight. But if you think back to one of our other examples from a different lesson, remember we talked about like how something could be ages in a daycare? And there was one outlier at like 25, that's probably like the caregiver. In that situation, I'd probably exclude that one, if we're talking about the ages of people that attend daycare, right? So use like your critical thinking skills for that part. Why might they exist and should we exclude them? Questions, comments? All right, so the main goal today was, can you identify outliers and know what to do with them? So I think we covered that. There are more examples on your note sheet that you can probably find in Schoology. If you want to, I'm always holding you accountable to what we do in class for that. But these are your notes. You can make them nice and helpful for the quiz, which is tomorrow officially. You do have 2 practices, so I can give you the last 10 minutes to work on that now. They're both pretty short, so you might be able to finish them in class, at least one of them. But if you have questions, let me know as you go. I do Schoology have the study guides published. After today, there's really only 3 more lessons after we do. So we are almost to the end. At the top of your Schoology, you really can't miss it. I don't put it in any folder. Is the study guides. They will be a grade eventually, but if you want to get a head start, this is what your test will look like. There might be a few things you don't know how to do yet, but for the most part, we're almost done. Whenever you get bored and want to start it soon. Okay, good. Any questions? Okay.